Hey guys, how's it going? Recall from our last lesson, we learned about the quadratic formula. And the quadratic formula is a set of solutions to a quadratic in the form of ax squared plus bx plus c is equal to 0, where a, b, and c is in the set of real numbers and a is not equal to 0. If that's the case, then x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. So for this second part, for our new set, we're going to have the quadratic formula part 2. There's a second part to it, and we're going to be taking a look at a specific part of our quadratic formula. And that specific part is this right here in my radicand, this b squared minus 4ac, and we're going to be taking a look at that. That has a specific name, and that name is what we call the discriminant. Okay, that's what we call the discriminant. The discriminant in the quadratic formula, right, is the expression b squared minus 4ac. And what's very special about that is that it can tell me certain behaviors about my graph. It can tell me certain things about the solutions to this equation, right? Depending on how you're looking at it. If you're looking at it graphically or if you are looking at it algebraically. Okay. Now, certain things happen, right? Certain things can be determined based off of this certain value here, right? And we're going to be taking a look at the number and the type of solutions. Okay, types of solutions. Let me go ahead and move this up a little bit right here. All right. So um, now certain things can be determined based off of the value of this discriminant, this b squared minus 4ac. If this discriminant is negative, all right, if it's negative, then we have two complex solutions. Two complex solutions. So if my discriminant is negative, we have two complex solutions. And so based off of that value, after I calculate it, then I can determine, okay, I have two complex solutions. If the discriminant is equal to 0, right, then we have one real solution. One real solution. And finally, if it's positive, and if it's greater than 0, right, then we have two real solutions. Now, if we take a look at this graphically, the solutions will be our x-intercepts. We're going to be taking a look at it graphically in just a bit, but let's go ahead and let's calculate these here. Okay, let's take a look at a couple of examples. And for these, let's, for the following, what we're going to go ahead and do is we're going to determine the number of solutions following expressions, determine the number of solutions and the type of solutions. Type of solutions. This right here says type. I know my handwriting is terrible. Okay, so let's go ahead, let's take a look at this one here. We'll call it number 1. And my expression is x squared minus 6x minus 16. I'm going to use a discriminant in this case here to determine the number the number and type of solutions. Okay, so if we recall from our quadratics, I'm going to find the value of a. The value of a is 1 since it's just x squared, right? The value of b is equal to negative 6 and c is equal to negative 16. Now my discriminant, I'm going to go ahead and take my discriminant. My discriminant tells me that it's b squared, so negative 6 squared minus 4 times a times c, negative 16. Okay, Now let's go ahead and let's calculate this here. All right, I'm going to go ahead and I'm going to put a parentheses wherever a variable goes, right? So squared minus 4 times 1, close that up, minus 16. Let's see what we get. 100 is equal to 100. So my discriminant, let's see what category it falls in under. Positive. So we have two real solutions. Since the discriminant is positive, this expression has two real solutions. This quadratic has two real solutions. Okay, so let's go ahead and let's take a look at what that looks like graphically. Now, if I take a look at this here, take a look at that. My solutions are -2 and 8. When y equals 0, these are the values of x, -2 and 8. Awesome. So let's go ahead and let's take a look at the following. The next one, okay? Let's take a look at this one here. We're going to go ahead and run this quick since we should know what we have to do next. Sorry for the bit of a delay. X squared plus 36 is equal to 0. Notice I don't have an x term. I have an x squared term and I have a c term, but I don't have an x term. Therefore, the value of b is equal to 0. Since I have an x squared, a is equal to 1 and c is equal to positive 36. 36. So now what I'm going to go ahead and do is I'm going to go ahead and use a discriminant. I'm going to use b squared minus 4ac. Okay. In other words, I'm going to go ahead and let b equals 0, right? 0 squared minus 4 times 1 times 36. Okay, so 0 squared is equal to 0. Okay, minus 4 times 1 times 36, that's equal to negative 144. Now let's go ahead, let's see what happens when I calculate this using only the discriminant. Check it out, minus 4 times 1 times 36. Let's take a look at this here, negative 144. Okay, so you can use this calculator, this setup, right? And what goes in the parentheses are those values of a, b, and c. Okay, now let's go ahead and let's say the number of solutions and the type. So since the discriminant is negative, this quadratic has two complex solutions. Okay, and let's take a look at let's see what that looks like graphically. Check it out. I have no x-intercepts. The previous one, I had two real solutions, and they crossed here and here on my x-axis. Now up here, it's way up here at 36, right? That's my y-intercept. But notice I have no x-intercepts, and it'll never intersect the x-axis. Therefore, I have what we call two imaginary roots, or two complex solutions, all right? But they are not real numbers. So there we have it.